This is my first video, and in this video, we'll be talking about house price prediction, which is sort of like the first competition every beginner has to go through. And I just thought ki before starting advanced level things, I just should cover the basics of it first. Okay, so let's get straight into it. Okay, I will not take much of your time. So the goal of this competition is to predict the sale price of each house, and for that you are given approximately 79 features, and those 79 features are describing, okay, what is the bathroom square feet, do you have a garage or not, does the house include a pool or not. Such kind of features are available, and yeah, and given those features you are said to analyze all the to predict the price of the houses. So this competition has a lot of things to explore, but what most beginners do, and myself included, have made a mistake is that we haven't concentrated much on the EDA part, that is the explanatory data analysis part, and the next thing being that the modeling is not up to the mark. So I guess we will be focusing majorly onto these two areas and probably try to cover all of this. Um, yes, so let's go. Let's get straight into it. Firstly, we'll be seeing some of the discussions like which led to most no the major discovery of what all things I have discovered are through the discussion panels. So firstly I'll be going through them. So khulja sim sim. Okay, it may take some time to load. So I have opened a few discussions at beforehand. Firstly, how we'll be progressing is like firstly we'll be discussing some simpler solutions and then probably going to the more advanced solutions of the competition. So first solution we have is a solution which is very simple in approach, but still I'm very much surprised that this simple approach can get you into top 20% of the competition. Hence, let's see what they have given in this competition. Okay, so this notebook is by this person, I don't know. Anyways, so the major crux of this notebook is the simple design of it. They have just imported a few libraries and nothing fancy. They just did some pretty simple EDA stuff and then made a model, but with an optimization technique, and that led them to a top 20% of the leaderboard. The first technique which they have used is to probably model their data. Firstly, the pre-processing of the data. So the pre-processing of the data is done probably by what do you say that, yeah, null value imputations. So their handling of null values, their missing values, and the outliers, also their feature engineering part. These are the three things: null value imputation, outlier detection, and feature engineering are the three crux of how you are going to approach the data pre-processing part of this competition. So firstly let's try to doing it. Okay, just a second. Okay, first things first, this data set is having 79 features, which means that some of them are having null values also, some of them are object types, that means categorical, and some of them are also numerical. What this means is that we have a large variety of data features to deal with. So what they have done is the handling of missing values, the number one point, will not be going through the code right now, but I am just giving you an overview of how the competition they have approached. Okay, so let's do it. Okay, This is the missing values column, and what they have done here is they have separately made different code blocks for categorical variables and for numerical variables. What they have done is for categorical variables they are imputing none instead of zeros, because of this reason that if you have a categorical variable, okay, and let's say it has to be either, let's say, a true false, or if let's say it was some street name, so that means that if there's a house, that house must be situated onto some street, and if that street is missing, then that means that either that street is not available, okay, and or if there's a null value there, okay, that doesn't mean that the house itself doesn't exist, that just means that there is some null value, hence they are just imputing a none here. Similarly, the similar logic follows on for different variables. They have handled it very beautifully, and probably in the further coming notebooks which we'll be seeing, every one of them has a specific kind of approach to dealing with these feature handling thing. So what I understood from this competition is the more better you treat your null values, your outliers, and your feature engineering part, the better your score will get, no matter how simple or how complex model you make. It all boils down to how better you are making your data ready for the modeling part. Okay, so then they have filtered out the outliers using the scatter plot and the box plot. This is called a scatter plot, this is called a box plot, where they have identified that if you have a house which is greater than which is having a living area greater than 4,000 square feet, they have just simply filtered it out, and hence this is how they have simply handled their outliers. The next thing is just plots, which we can skip over. The next is feature engineering, which is very beautiful part of this notebook, that they have converted their categorical variables into numerical variables, which means that the categorical variable will because every model needs to have their inputs as numbers. So what that means is that that a model needs to see its inputs in form of numeric values, not in form of categories. Hence what we do is it just does pd.getDummies, which will just simply create a different integer column of a different categories in the column. If you are not familiar with it, you will just have to do a Google or like what is get dummies of pandas, and you will find more information onto it. The next thing which is very much interesting was the modeling part of this notebook. That was that they have just made one model and then optimized it to do the rest of the things. Firstly, they have made an XGBoosting model. That means they have made, if you are not familiar with it, extreme gradient boosting, which is sort of like the earlier version of a neural network, but not with the fancy stuff of neural networks. Hence, if you are using XGBoost, you probably may won a lot of competitions using that, which are using tabular datasets, but probably neural networks then came after it. Hence, XGBoosting is a really great algorithm to if you want to try it out. Okay, so what we do here is we are using hyperopt for hyperparameter tuning. So what we do is we are making our parameters, we are just declaring our parameters, and then what we are doing is making an objective function. An objective function is a function which goes into the hyperopt object, and then you will pass in the different parameters you see here, on which because of which you can then train your model and then do the other rest of the normal ML stuff. But what's more important here is that the modeling part along with the optimizations gave you a result which was worth to be in like top 20%. Hence, this was the beauty of this notebook. Never forget to upvote a notebook. So I have upvoted it. Let's move forward. The another thing which another cool discussion I found out was by Yam Pelek. This discussion was about the feature selection guide. Okay, that means if let's say you have 79 features, out of 79 features you must be selecting a few features which are not of any use to you. Hence, how do you do that? So for doing that, you must have a strong feature selection technique. I have seen many notebooks where people are using heat maps for correlations, and then probably dropping the higher correlated columns to avoid multicollinearity issue. But that is not the case every time, and it won't work every time. Hence what we do is hence what Yam is suggesting is to use a technique which is more generic towards feature selection. Hence, one of the techniques which he is suggesting in this post is called as LOFO feature importance. You can follow the other posts also, but for now, I would just say that this LOFO feature importance is one I find most interesting. If you want a link of this, I'll just paste it in the discussion or live chat. I don't know if, but yeah, this is my first stream. What do I expect more? Anyways. Exactly, yeah. So let's go over the LOFO feature importance so that we can understand more about how this thing is working. How do we execute a feature importance script? Okay, how do you find out which features are important and which are not? So for that, we are using LOFO. I will explain it how to use it now. Firstly, you just start with your standard imports, standard data pre-processing, and when you have a final data pre-processed and ready, what you do is you pass this through your standard sklearn model. What you do is just firstly install LOFO importance. Since now that you have installed a LOFO importance, you will probably be now having so after installing LOFO importance, you just import dataset, LOFO importance, and plot importance. These three are the key lines of these three imports will help you to make proper feature importances. So the thing is that LOFO, why I personally liked it, is just by using 3 or 4 lines of code, you'll probably get all the feature important stuff. Because correlation sometimes is a bit trickier to understand, and hence we are using LOFO, because now you just create a LOFO importance object. Inside that you pass dataset, and then whatever your scorers are, then you just say get importance, and that's it, you have it. This is the most easiest yet effective way of handling feature importance task, and this is sort of like the most generic way and authenticated way I found to sort of find the feature importances. Then the next thing which I have found the most interesting was because now we are moving to the more advanced code and data pre-processing and modeling part of the competition. So there are 2 or 3 notebooks specifically I have found very interesting and very intriguing. Those notebooks have some stuff which are very much important for a beginner. Like, I skipped over it myself and I still regret it. But one of the most important things which I have known is that you have to get your hands dirty, and still date I was not aware of this technique, whereas I should have known this technique from the beginning. Hence what I will now say is that let's get into it, and then probably we'll discover about what I'm gonna show you. Okay, so this is a kernel by Nanashi. Okay, let me upvote it. Yes, I have already upvoted it. Okay, so this kernel will be dealing with EDA, the first thing. Second being feature engineering. Third being modeling and blending. What's blending? We'll come to that part later, but first is exploratory data analysis. Now what they have done in exploratory data analysis is very novel, and I haven't seen that in when I started out, um, because I obviously skipped over it. I should have seen it, but for you guys it will be like that EDA is the most key part to this competition, and hence we are going to discuss how this strong EDA is making a very good impact on the leaderboard of this Nanashi guy. Okay, so let's get to his solution. Okay, here goes. There are a few things which are still very much what do you say, I'm not aware of, but when once I was going through this notebook, which is like very beautifully written notebook, I found a lot of key insights into it, and probably those are the things which I am going to share with you right now. Interesting. Well, let's do it then. Okay, so first things first, what he has done, he is using blending, and we'll be coming to that thing later. And let's start with the EDA. Where is it? Yeah. Firstly, we have 1400 rows in the training set and 1400 in the testing set. So out of which you have approximately 36 as quantitative and others being categorical. Now what I want you to focus on is the not the quantitative part but the categorical part. Like, we'll be focusing on both obviously, but categorical part is a bit trickier to deal with, because in categorical part you have null values. Also you have to encode them separately into different columns sometimes, so their encoding and their null values becomes a little bit trickier to deal with, whereas quantitative part has its own counter challenges. The number one being they have outliers which the categorical features do not have. Then you also have the null value imputation task, which is more trickier in the quantitative part. So we'll be discussing both of these approaches in this notebook side by side. Okay, so how they are doing it and how we will now have our own perspective of how to make it work. Okay, so first things first is the null value. The issue of null value is the elephant in the room, we should say. I should be addressing right now, and that is that most of the variables here are having a lot of null values. So how do we deal with those? We'll be seeing that in the later part of the notebook. So let's skip and come down. Yes, here it is. So first things first, ID is a column which we do not need neither in the train set or in the test set. So what do we do is drop them, swaha. Next thing is that as I said that earlier, that every notebook is sort of following the same convention of exploratory data analysis. So you won't be finding much difference in the two of or in the notebooks. So firstly, if this notebook is having is also filtering the outliers or the ground living area. Okay. Also this notebook which I just showed right now, where was it? Yep, this was also filtering the same thing. You see that? Yep. So kind of like the same strategy goes on, but just with advanced modeling and some advanced feature engineering stuff. Baki, the base remains the same always. Let's move ahead. If I could have a larger screen, yes, thank you. ठीक है I have 2 views on this live stream, which is okay, I am not much ashamed of it because I am still learning. Okay, the next uh, s- part of this notebook is about feature engineering, which is how which is what differentiated this person to be in the top 1% and the other person to be in top 20%. So this is where all the difference was made. Okay, so cool. Here we are given um, two sets, the first one being training and second one being the test. What cool trick they have done is that, let's say if this is train set and it has a lot of null values in it, and this is the test set with no null values, what they have done is they have concatenated these two sets and now you have a bigger data set. The only problem I have with this approach is the problem of data leakage, which is being addressed in one of the discussions by a grandmaster. And what is the problem of data leakage? I'll be explaining you right now. Let's suppose that this thing has a lot of null values, and this is our train set, and this is our test set, which we will be using for making predictions later, for the forecasting later. Okay, predictions or forecasting, whatever. So if this data set is having null values and we want to impute, let's say, mean into mean of this whole data set into this column, into this row. So what we do now is total of all this, that means including the test set. Now the test set has its own different kind of distribution, and this training set has its own kind of distribution. What now will end up happening is that the characteristics of this test set will certainly come into the training set without even because we want more data to be imputed, hence we are using the test set. But this is a approach which I found a little bit controversial, but since they are grandmasters, they are doing it, they are getting results. I guess for competition wise, or like for time sake, I think this is okay, but for real world application this is not at all accepted. Hence for like competitions you can use the simple hack of stacking them up and then using the average of the whole thing, but in real life it should be a big no. Moving on, we are doing the feature engineering part. Feature engineering means they are, see this, they are concatenating both of this. They are filling null values now. Okay, so standard way of filling null values is by using fill na, and then some, if someone needs to be none, it will be none, someone needs mode, it will be mode. And yeah, moving ahead, lot frontage. Okay, how are you using different features to fill in the different values? Okay, so what they have done is they took lot frontage, they grouped by neighborhood. That, let's say if there is a certain neighborhood, okay, and every neighborhood must have like a standard plot size, okay, and that plot size will be sort of like an average of in the every row house thing. Okay, so let's say if there are houses which row houses having like average square foot of 2000 or 3000 square feet, so the average of a lot frontage in that particular neighborhood will be always obviously 3000. You cannot say that your neighbor's house is 4000 square feet. It would be completely unjustified. Hence they are just grouping everything together so that everything every lot frontage of the same neighborhood should have the same plot size. That's it, that's what they are doing, and they are just filling it with the median value. That means that it should not have much of the outliers, neither should be average of everything. So they are just going with the normal middle value. Okay, it's tiring, yeah. Going live is tiring. I never thought that this would be a constant. Okay, but anyways, it's been half hour already. um, the next thing is that for numerical values, if anything is not present, they are just filling it with zeros. That's it, they are not doing anything else. If you move forward, you will probably find that if your data set is skewed, I guess they are just like, what this line of code is doing is that if your data set is having skewness in it, it is just making it more normal using the boxcox normal function. That's it, that's nothing else is complicated. If you don't know what this thing is, just do a plain Google search, you'll find it what this function is doing. Okay. Now comes to the most interesting part and the key highlight of this notebook, that is the feature engineering part. This notebook stands out most because of this particular section of notebook, which you are right now seeing. Because of this feature engineering part, they were able to score in the top 1%, and this person was not able to. So it makes a huge difference. Let's dive straight into it and understand what they are trying to do. So if you are having a house, okay, and let's say I made a house in 2020, and after let's say 15 years, that is in 2035, I remodeled it. That means my year of remodeling and year of build are two different columns. Now what they have done is they sort of combined both of them into a single column. That means this is a new feature which they created with the existing features. Now what will happen is these two features will lose their existence, because now we have one feature which will be representing both of them. Similar thing is happening in the code box down below. That is, if you have total number of bathrooms, instead of just counting full bath, half bath, basement full bath, they made a column with total number of bathrooms. That how many bathrooms, instead of counting how many total bathrooms, half bathrooms, full bathrooms, they just said a big no. What they just said was, you just need to have the total number of bathrooms, okay, as a column. That's it, nothing else. What next would be is that this is the sort of, what do you call it, these are Boolean variables. So what they have converted now is, if you have a pool area which is greater than 0, now you will have a pool area. If it's greater than the 0, that means you have a pool. That means you will make a variable called as has pool, that is true or false. Instead of having a specific number of pool which does not contribute much to the data, it just transformed the pool area into has pool, which will contribute significantly much more than pool area. Then since you have combined the two, just a second, calculator. Okay, since you have combined two of them, that was 1460 plus 1460, and then you have sort of dropped a few columns. That means now you have a shape of how much, 2917 instead of like 2920. That's a really simple math, right? What do we do next is conversion of categorical variables into numerical variables. That's it. So that's what they have done here. It just said pd.get dummies feature and then reset index. That's it. This is the most crux, the most key highlight of this notebook, that the beautiful feature engineering made it stand out so well that it went into top 1% of the notebooks. I guess if you understand this part of the notebook, you are good to go, and probably you will also score into top 10 or top 15% of the notebooks. If you just follow this notebook, probably 1%, 2%, who knows. Anyways, let's move ahead. Okay, what now it is doing, this is the modeling part. Okay, now while you are making a model, the most important part of modeling is that your model should not overfit. Okay, and your model should be able to generalize better. So what they have done is they have used different kind of learners. Let me tell you this kind of approach. Okay, they are using a kind of approach named as blending. They have named it blending here, but now I'll tell you how the blending will work. They are using, let's say, 5 or 7 different models, and then using all of these 5 7 models to make one model, and this one model will make a prediction. Okay, now how are they doing it? I'll tell you exactly in a moment. Okay. Okay, so here they have started their k-fold cross validation loop. The next, they have used the root mean squared log error. If it's not log error, I guess that's a typo, I don't know. And then they are using the same thing in a cross validation loop. That's it. I don't think so we should be addressing these parts right now, but what they have just done here is to make a pipeline which will, okay, what's a pipeline? First of all, a pipeline is a sort of function in which your data will come in. Okay, so let's say if the pipeline starts from here, so your data comes in, it first goes through the robust scalar and gets the data scaled for the particular modeling stuff. Then probably what happens is it will go into the next stage, that will be to pass through the ridge CV. Okay, now what is ridge CV? Ridge CV is nothing but ridge regression with cross validation. So if you want to do a ridge regression followed with an in-house cross validation loop, it will have, you will use ridge CV, lasso CV, elastic net CV. That's it. I guess I have made a point right now. Okay, so kind of every approach will follow the same kind of pipeline. And then what you do at last, okay, so you are making how many models? 1 2 3 4 5 6 7, that's it. Okay, so now you're using 7 models, and you're using these 7 models and kind of like stacking them up. Hence you are using stacking CV regressor. Now why are we stacking it? Because stacking is a pre-process of blending before you blend your models. So firstly you need to stack all the models, get a prediction from out of it, and then probably just blend the models together to get a better prediction. How this is working, we'll just see it in a moment. Okay, firstly we are using stacking CV regressor, and then probably using stacking them all up and making a model. So stackgen is a model. Now in the next code step, we are just taking scores of different models individually. Okay, so these are the individual scores of the model. The next step which we do is stackgen. Stackgen is what your stacked models in one stored in one sort of, what do you say, your stacked models in this sort of object. So you are fitting your x and your y onto stackgen, and then probably again fitting all of the individual models to see what performs better, a stacked model or elastic model or like lasso model, ridge model individually. So now that we have fitted everything, we will see a naturally blending of models. Now how do you blend models? The approach is simple. The model with a lesser score will get more weightage. So sort of like I will say, how do I state an example? Well, right now I don't have an example, so that we'll look at that later. But firstly, Let's see. We are now weighting the models. Okay, that means if you have 0.1, you have 0.1, you have 0.05, you have 0.15, and you have 0.3. Now out of 100%, like let's say you want to predict something and you have an input in a model. Out of 100%, you have, like, let's say 7 or 8 models. Now out of 8 models, you are giving 30% of your weightage to the stack gen model. Are you getting my point? I don't know. So out of 100%, you give 30% value to your stack gen model, then 15% to your XGB model. Because if you are new to this thing, I'll tell you, light gradient boosting, extreme gradient boosting, stack gen model, these are more complex models. Hence, they are able to more capture more details and more generality of the data. And since they are like more sort of advanced algorithms, they are being given more weightage, because then they will be having a more say in the decision as to what then they will have more say in the decision as to what should be the final prediction. Okay, if you are getting my point. Well, let's see. The next would be that I guess that should be it, and that's how you predict using blending. Okay. Now we are left with 2 more notebooks, but should we cover it? The question which is that should we cover it? I'll say no. Probably because every notebook here on follows the same approach, and you can see that this notebook is having 611 upvotes, and I'll add one to it because it was a great notebook and I got to learn from it. But should we even cover the next notebook? The next notebook is by one of the best approaches to this data, and it is also having a gold medal in discussions. So I'll probably believe that it must be having another gold in, yes, it is having another gold in the coding section. Upvote it and let's discuss it. I said earlier that everyone is having similar approaches. Let's see if I'm true or not. So probably right now what they are doing right now is that it's just firstly normalizing all the data, which here Nanashi also did. Let me search for Boxcox. So if you're not aware of Boxcox Normax, what Boxcox Normax does is if you have sort of skewed distribution of the data set, what you do is you apply a transformation to make a bell curve sort of distribution. So for transforming your data set from skewness to, like, from skewed to a normal data set, you apply transformations. What this guy did was a log transformation. He did a log transformation, and what Nanashi did was a Boxcox transformation. So the method remained the same. The what do you say? The method remained the same, but your application or the feature which you used for transforming it changed a bit. Okay. And then again, this was the same thing, that they are probably then converting their categorical variables into numerical variables, then filling their null values, and then dealing with the outliers. Everything remained the same. If you see this here, they are dealing with the null values the same way Nanashi did it, the same way this golden user did it, I guess. Yes, the golden user. Yes. Well, the most interesting part of this competition was that instead of having so many approaches, we still had a very few people which were able to score better. Like, this person was in top 50, that Nanashi was in top 1%. Now how are these guys able to do it? Look, there are so many techniques, but there are just a very selected few techniques which you should be following. As a beginner, I also messed up this competition while I started 2 years back. But now I realized that how delicately important this competition was for me as a beginner, that I still till date didn't have known about this LOFO if I wouldn't have opened this competition back again. So probably I guess everyone will have to go through this competition, and the approaches may be different, but the results with all the combined approaches will always be the same. That is, you will be in the top percentages of the competition. So yeah, everyone is doing sort of the same thing. If I have to prove my point again, that would be that, yep, you can see this has pool, and this thing again. This is again inspired by Nanashi, but everyone else is using it, so I'm not the one to question it. And again, you can see this. They are stacking it again. Yep, they are stacking it again. They are using the same code which Nanashi used, and other people are in this competition still using the code. Even the weights are the same. Hence, I would like to conclude by saying that I have boiled down everything what you need for this competition. For house price prediction competition, you need only three things. Number one being proper EDA. Number two being proper feature engineering. That means from the existing features, you should be able to create new features and then probably use those features to make a great model. And then third point being a great modeling technique. Some of the people use optimization techniques to optimize their model. Some of the people use stacking, blending type of ensemble models, which were great. I'm not telling that some of the techniques are bad or good, but use the techniques which you think will get you a spot in the top places. Probably by saying this, I'm going to end this live stream right now. And in this next video, probably I'll try to come up with an advanced solution competition, and also I will be trying to make a notebook onto house price prediction with someone else. I'll try to collaborate, but if not possible, I'll do it alone. I guess that's it for today. I'm not going to stretch it out more because it's already 45 minutes of stream, I guess. So yeah, thank you so much for joining. I don't know how many people joined. I guess only 3 or 4 people were there, but it doesn't make any difference. I'm gonna do this again and again for 50 or 100 or 300, 400 videos, and I'm not gonna stop because I'm doing this for myself and I learn it better. Learn this way better. So if you want to join in. I don't mind anyways. Chalo. Goodbye. Signing off for now. Bye bye. End stream.